And so we want to try and focus today's discussion, I think, on stuff that may be, it's still sort of generically talking about, hermetic connectors and what we can offer, but really something that will really highlight the capabilities at Hermetic Seal and our ability to customize to set us apart.
Okay, to that extent, you have your list of questions here. I'm sharing that one, and I'll share this one.
Now let's walk through these questions.
Okay, the questions up?
Yep, great.
There they are. Yep. So
well, I haven't had a chance to answer them, but I can do it to write them down. But I can talk to it, or you can give me a couple of days to figure it out.
You don't need to write anything down, okay? Mm-hmm. We're just going to walk through these, and I'm just going to list. This is Rick Whitmire. I'm going to be writing the paper. I'm just going to listen to you talk. We're recording it, and there's no need to write anything.
I love it. Okay. So what is the connector product lines? It's basically, they're all the mil-spec connector lines that Sealtron provides, and those connectors are listed in that PowerPoint presentation. All the mil-specs are listed there. And what Sealtron does is when they're running at full speed, they make about 1 million connectors, ship 1 million connectors a month out of there, and most of them are they're based on the QPL product. People want to change the flange width. They want to change the flange mounting holes. They want to change the contact length. Instead of the mil-spec calls out for a flattened pierce or a solder cut, people want to put PC tails on them, and then they want to make them longer PC tails, or some long PC tails, some short PC tails. They want to leave some of the pins out to help. For one thing, they don't need all the pins. The pins just cost money, so you can leave them out. And also helps to when they're keying the parts, you can see if the contacts are missing. They can block off a contact on the socket side, so you can't get a mismatch. Not used very often that way, but it is an application. But most of the time, it's modifying the back end of the connector. We call the wire end of the connector. The mating end of the connector is all to mil-spec. You can't modify those at all. That they have to be able to mate with the other people's connectors out there in the industry. And on the main connector lines, the 38999, 2642, 83723, which is equivalent to the European EN 2997 and the ESC 10 and the ESC 11. All of those have probably 150 other manufacturers that make the plugs that mate to our receptacles. So they all have to maintain intermatability and interchangeability. That's a given. You can't mess with the front end of the connector. So the back, they might want to put an O-ring because they're going to have an O-ring compression groove on the back where they're going to bring it down. They want to make sure they have a good seal from the back of the connector to the housing. If you go, you can see some of the pictures I had on the other presentation. You'll see more parts there, but basically that's what it is. It's not overly complicated. It's just making minor changes. Somebody wants a little bit larger flange. Somebody wants a smaller flange. Somebody might want a weld flange. These are all the things that we would do to make it customized. But again, it's all fireside.
Okay, so what are the markets that we're focusing on? Mike and Gary, is this aerospace and defense, or is this a broader market group for the paper?
Yeah, so I think the primary targets want to be about the aerospace market specifically. The defense, just for a variety of reasons, is very difficult for us to crack in Europe. I think mentioning defense and energy and a whole series of other things that were listed in the PowerPoint there, those kinds of applications are fine. But for the core primary market we're really trying to target here is the aerospace market.
It's commercial aerospace.
Right.
It's basically
commercial aerospace.
What you're mainly looking at is Boeing and Airbus.
Right.
And obviously Airbus is the big guy over there. But that are the tier ones. There's 100 tier 2 suppliers into there. And we're calling on the tier 2 suppliers, whether it be Zodiac, Liebherr, Meggitt. I mean, I can get you a whole list of other company names that we're dealing with over there in Europe.
So like the last paper, which was European focused, is this one also European focused, or is this global?
Well, the project itself is European focused. We don't want the paper to be so tightly constrained that, it doesn't really apply outside of Europe. But really we're trying to achieve better traction in Europe is the primary goal here.
Okay, great.
And I thought you did it perfect last time where that first paragraph mentioned SkyDraw, for example, right?
Right.
To just use the European common language term that U.S. people would know too, but they
know it's theirs.
Mm-hmm. Good. Good. So, I know in this case, we obviously last time we were trying to reach purchasing people. This time we're looking at design engineers at the tier 2s. Is that the target for this?
Yes, sir. That would be who you want. We're going to want to go into that we can provide custom solutions. If they want a mil-spec connector, they can go to the websites or the DESI website, and you can pull up a QPL and you can find 200 suppliers of QPL product. We're going to differentiate by doing the custom products there.
Now,
modified QPL products is the key.
Say that again, George. Modified
QPL products. QPL is qualified part listing.
Okay, good. So, when you look at the at design engineering, who makes the decision on the connector manufacturer? Is it a design engineer? Is it an engineering manager? Is it purchasing? I mean, who's gonna make that decision?
Typically, when we're working with an engineer, they'll specify us and put us in what they call either source control drawing or suggested supplier drawing, suggested source of supply drawing, and that's what we want to get on, because that way, engineering is controlling a dimension that they want controlled to a specific dimension. It's usually a tighter tolerance of some sort because they've got a problem or they've got a PC board or something. So if we get on that with the engineer, we don't have to worry about the buyers going out and shopping us.
Okay. That was what I thought. When you're doing customization, that's a lot different than buying a standard part. Yeah. There, the engineer has a lot more control over who they're going to work with.
And it's harder to find those people nowadays because we can't make sales calls, not because of COVID, but because everybody's been shut down since 9/11. You just can't walk into a Northrop Grumman or a Liebherr and say, "Hey, I got some connectors here to show you."
Mm-hmm. Right. Exactly. So.
There's also, George kind of made light of the customization we do, just, drop a pin or change the flange or whatever. It turns out, there's probably a lot of companies that could do it in principle, but yes. We're basically set up to do that. So we're actually very fast, flexible. We're good at it. And it's not so easy to get the connector exactly the way the engineer wants. So we're one of the few companies that'll say no problem and give it to them.
Okay, and that's good, Michael. We're gonna dive into that a little deeper here in a minute, but that's a really a key point. So putting yourself in the place of one of these design engineers, when it comes to evaluating connectors and the kinds of things that they need, what are the problems that they face, and what are the drivers of customization? I'm trying to understand, what moves them to customization and away from a standardized product.
Okay, typically our part is going to be on a box of some sort. We're not on the cables and the wires and flying around in the plane. We're going to be in a box. Somebody's made a monitoring system of something, whether it's fuel, vibration, or whatever. They've got a box, and they need to go from the inside of the box to the outside of the box, and every box is a different size. Some are bigger boxes, some are smaller boxes. Some got PC boards right up next to the flange. Some of them have PC boards back to the flange. So it's how they attach a connector to their box that causes the customization.
And, from what I've seen, there are a lot of standardized products in all shapes, sizes, pin numbers, blah, blah, blah. Why would I want to customize when I could just, and go through that cost and time.